In this problem, what we're going to do is we're going to sketch the graph of these functions and then find the Laplace transform of these functions. These are unit step functions. And so the way we can think of a unit step function is that it turns on, and then when I add it, I turn something on, and then I subtract, I turn it off. Add, turn on, subtract, turn off. So what are we turning on here? Well, let's pick this color here. It's the function is 0 all the way up to 2. And then it turns on at 2, but then we subtract it at 3, so it turns off at 3. And then it turns on again at 4, but we multiply by 2, so we're up here. And then we subtract off the 2, turn that off at 5, and it keeps going. And at the endpoints, we should make open circles. So that's the way it should be. But that's sort of not really that important in many ways for what we're doing, because we're taking the Laplace transform, and so individual points are not what we really are concerned about when we take the Laplace transform. And so it's possible even the fact that unit step function might be defined a little differently at the endpoints depending on the book you're using. Okay, and so we're going to use the formula that the Laplace transform of u to the at is equal to e to the negative as over s. So therefore, the Laplace transform of g is e to the negative 2s over s minus e to the negative 3s over s plus 2 e to the negative 4s over s minus 2 e to the negative 5s over s. That's our answer. One hopes. Okay. So, I mean, the formulas are important, and that was written up here, that on a table, way up here, that the table that UAT is e to the negative as over s. So we have that, and oh man, lots of work done here. Okay, so this one here is a little bit more of a challenge. What this is that it's turned off. The function here is turned off all the way, and starting at 0, but then it turns on at 1. And what does it turn on to? It turns on to t minus 1 squared, which is a shift of t squared to the right. And so we'll just go ahead and put that parabola here. So that's, could show more points, but we have that. Okay, and so the Laplace transform is given by this formula UAT f of t. Well, this is t minus a. We have this formula that we can use. And this is e to the negative as f of s. So we have that formula. We also have to use the formula Laplace transform of t squared is 2 over s cubed. So putting those together, we have shift by this 1, so we'll have negative 1s, and then we'll have Laplace transform of t minus 1 squared, which is 2 over, made a mistake, sorry. So this is Laplace transform of t squared is 2 over s cubed. So we'll shift that by 1. And that gives that. This next one, we have the function turns on at pi. So we turn it on at pi, and so 0 up to pi. Oh, well, I mean, I'm not going to use the scale of, yeah, I might. I mean, pi is 3. Why don't I try it around 3? I'll make pi up here at 3. Let's do that. So here's pi. And then I turn on this function sine of 2t minus pi, which is shifting sine of 2t to the right by pi. And by the way, the period is p equals 2 pi over 2, which is pi. So so here's 2 pi, and we'll go through one cycle in that amount of time. So it's going to look like this, and just it'll keep going if I can achieve that without making a mess of my paper, etc. Okay. So keeps going on. All right. So then I'll use this formula that I have above here, but I need also that somewhere along the way, the Laplace transform of sine of bt is b over s squared plus b squared. So capital F of s is what we're trying to find. It's going to be e to the negative pi s because of this part here. And then f of our function. Okay, so then we have our function. Okay, so let me just point out that Laplace transform then of sine of 2t minus pi so that's what we're going to try to find here. Is okay. So we have this. We're going to. So according to this formula, we have the Laplace transform of. I have to multiply by the Laplace transform of sine of 2t. So the Laplace transform of u of a f of t. This is supposed to be a right here. The Laplace transform of ua ft minus a is e to the negative as f of s. All right. So according to this formula, I have the e to the negative pi s, and then I have Laplace transform of not sine of 2t minus pi, but just sine of 2t. And then I'll use the formula that I have here to the right. Okay, so we have that. Okay, so that's that.